Hello everyone, welcome to the class again. Today we will start with a new unit, that is unit 2 of your syllabus. This unit basically contains electronic voltmeter, its advantages over the conventional one which we have dealt with in first unit. और इलेक्ट्रॉनिक वोल्टमीटर में भी एक स्पेसिफिक टाइप का हम लोग वी विल बी स्टडिंग इज एसी मिली वोल्टमीटर, yani voltmeter which could measure up to the millivolts. So this is a brief about what we are going to study in this unit. So let us begin now. So it's electronic voltmeter. Okay. The word electronic has a lot to say about itself. These days we talk about electronics. A whole course is being put in physics honors specifically, and in various other courses, physical science, on electronic equipments or some sort of courses there. So why this is so important for us to know, to be aware about that, is in the history of technologies, electronic technologies play a very important role, because if there was no electronics, we couldn't measure anything. We couldn't measure the mass of electron, we couldn't measure the charges on the electrons, we couldn't measure the amplitudes of the waves produced, and many more things like. तो ऐसा जो भी आज हम चीज़ें जानते हैं, वो अगर हमारे पास प्रॉपर इंस्ट्रूमेंटेशन नहीं होगी तो वी कैन मेजर देम. We can't verify our theories. We can't verify theories put by different scientists. So measurement is something very crucial for the development of a nation and things like that. So now what is electronic instrumentation? एक बहुत ही वाइड शब्द है. इसका क्या अर्थ है, क्या मीनिंग है? Whole lot of technologies are involved in electronic instrumentation. Right from the beginning of, you can say, the understanding of semiconductors, the electronics started, because the whole electronics revolves around these semiconductors, semiconductor materials, semiconductor elements. So we can start from there. So it combines a lot of technologies ranging from 19th to the 21st centuries. So that is the history about it. But still, a lot of electronics is being developed, but still we continue with the instruments such as Wheatstone bridge, which has no electronic component in that. Wheatstone bridge में क्या होता है? Simple. 4 resistors are there, one normal analog or non-electronic galvanometer is there, connected across a battery. And मतलब इतना electronics develop होने के बाद in the laboratory in today's time as well, we continue to study with the devices such as Wheatstone bridge और कन्वेंशनल वोल्टमीटर्स जो हमने पहली यूनिट में पढ़े हैं. अभी ये डिफरेंस आपके दिमाग में और क्लियर हो जाएगा जैसे जैसे यूनिट आगे बढ़ेगी कि what is conventional, what is electronic voltmeter, what is analog, what is digital. We all will be going through it. But let me have a brief, let me give you the brief background of it. So that is why. So on the one hand, we have much advanced electronic technologies, but at the same time, we are continuing with our Wheatstone bridges like instruments which have no electronic things. So we need to know both the things, hence both the topics are in our unit. First unit basically deals with non-electronic one, or you can say conventional. Second unit will be dealing with electronic one, and the last two units of your syllabus will be dealing with the digital ones. So उन तीनों का crisp understanding I will be giving here only. So you can very well see the scientific and technological progress of any nation depends on its ability to measure, to calculate, and finally estimate the unknown. That is the beauty of it. If you want to progress, you need to measure it very accurately. So in today's time, our standard units, जैसे कि हमने मास को पहले define किया था, कि what is 1 kilogram, वो भी उसको redefine. We are continuously redefining to be more precise and more accurate. तो वो कैसे आएगा? Measurement से आएगा. ठीक है, तो लाइक लेंथ पहले एक पैलेडियम का बार के सेंस में हमने एक पैलेडियम का बार की लेंथ लेकर के कि दिस इज 1 मीटर ऑफ लेंथ, उसको लेकर के स्टैंडर्डाइज कर दिया और फिर सारी कंट्रीज वही लेंथ को 1 मीटर मानने लगी. बट इन द लास्ट ईयर वी हैव रीडिफाइंड इट अगेन. उसी तरीके से हमने 1 किलोग्राम को भी रीडिफाइन, वी आर हेडिंग टूवर्ड्स इट. 1 सेकेंड का मीनिंग क्या है, कैसे हम 1 सेकेंड को मेजर करेंगे? तो कॉन्स्टेंटली इवॉल्विंग प्रोसेस. सो वो इवॉल्विंग तभी बेटर होगा इफ वी हैव बेटर इंस्ट्रूमेंटेशन, एंड इलेक्ट्रॉनिक टेक्नोलॉजी इज द वे फॉरवर्ड, is the technology of the coming times, and it is constantly evolving as well. So the success of an engineer or technician is judged by his ability to measure precisely and to correctly interpret the circuit performance. There are three ways of making such measurements. अब precisely measure करने के क्या क्या तरीके हो सकते हैं? What are the methods available to us? Now here slowly we are entering into your syllabus part. First is by mechanical means. Some kind of mechanical movement is there, like हमने PMMC meter in the first unit we have dealt with. There is a pointer and it is moving. A mechanical motion is there. Similarly, your pressure gauge. The piston continuously moves and you measure the pressure. So they are the devices based on mechanical means. Second is electrical means, by means of like your electrical voltmeter. So you are giving it a supply, a battery is connected or something like that, and then it is measuring ki what is the amount of current, what is the amount of voltage is there. So that is, in any sense you are using the electricity, you are using cells, है ना? You put cells in your watch or in your clock and then it runs and then it shows the mechanical movement. So you can put roughly those clocks in electrical means. Now by third is the electronic means. Electronic means, and there is very similarity between the electrical one and the electronic one, with one basic difference. Here you use means of amplification or attenuation. In case of electronic, basically you use some kind of transistors, some kind of diodes, means some kinds of semiconductor devices are being involved in electronic devices. So, and not it is not necessarily that you use those semiconductor elements in case of electrical. So this is the basic difference between these two, electrical means and electronic means. So your mobile phone you can put in this electronic means, and more better say we'll further be dividing into digital ones. Electronic में there could be two kinds of analog electronic or digital electronics. So we will be dealing with it. So your mobile phone you can put in case of digital electronics. So electronics devices are those which in any format uses diodes, uses transistors, uses amplifiers, uses transducers and all such kinds of things. Those devices are electronic devices. Now, how the electronic instruments are better? Why? What is the need for them? How are they much better? They have higher sensitivity, they have faster response time, greater flexibility than mechanical or electrical instruments in indicating, in recording, and also if you want to control the amount of current flown. Like here, if you take in PMMC meter, what happens? The movement of coil, the current I you pass through it, the movement of coil depends on the input current. But somehow if large amount of current is passed, this coil can get damaged. Here comes the difference. In case of electronic devices, if you want to measure large amount of current, this electronic device will attenuate this current, reduce its uh, voltage proportionally, and then pass into the circuit, measure it, and proportionally then afterwards increase and show you the exact input you supplied. So you can control the amount of current passing through the circuit as well, and the amount of current passing through the circuit can be controlled with the help of transistors. So controlling can be done in case of electronic instruments, which is not available in case of mechanical and electrical means. And that is the beauty of semiconductor. Semiconductor, what is semiconductor? What is so special about semiconductor? Metals are also conductors. What is so special about semiconductor is the ability to control the flow of electrons. You cannot control the flow of electrons in case of metals, but in case of semiconductors, you can control the flow of electrons. So that is the uh, beauty of semiconductors. Hence they are so special. ज़्यादा करंट फ्लो कराना है, कम करंट फ्लो कराना है, वो सेमीकंडक्टर से ही आप कर पाओगे. You can't play with the metals. So the power of controlling makes it special. So this is a brief introduction about your electronic instrumentation. Now moving forward, there can be in each case I am saying in electrical as well as in electronic, there you can have two types of displays or two types of measurement, analog and digital. So here comes the deflection type instruments with the scale and movable pointer are called analog instruments. जो pointer move करेगा, that is proportional to the electrical quantity being measured. This we have already discussed and very well seen how the amount of current is proportional to the pointer movement. Now, what is digital? And don't get confused between electronic and digital. There is a slight difference between the two. Digital instruments are those which use logic circuits and techniques to obtain a measurement and display it in the numerical form. वहाँ पर आपका कोई pointer type of चीज नहीं होता. Like in calculator. In calculator, what you get? You have this kind of display. This kind of display you have. If that is true, so these two will be like this. If it's one, then only this part will glow. Logic circuits means use of gates, AND gate, NOT gates, OR gate. So instruments which uses gates or logic circuits in their instruments, in those instruments are known as digital instruments, and obviously these logic gates consist of semiconductors, no doubt about it. So they are electronic, but इलेक्ट्रॉनिक है, लेकिन अगर आपने उस पर जो डिस्प्ले है वो एनालॉग लगा रखी है तो दैट इज इलेक्ट्रॉन एनालॉग इंस्ट्रूमेंट। लेकिन वहीं अगर उसकी डिस्प्ले 7 बिट डिस्प्ले है, लाइक इन कैलकुलेटर, डिजिटल वॉचेस जैसी अगर डिस्प्ले है, नंबर्स आपको डिस्प्ले हो रहे हैं, तो दैट इज डिजिटल इलेक्ट्रॉनिक्स। सो देयर इज अ डिफरेंस बिटवीन द टू थिंग्स। Your analog information, this is your analog wave, your analog information is converted into digital information. This signal is first sampled. Sample means broken into parts. At every point of time, information is quantized, and this analog signal is converted into the language of 0 and 1, which is the digital language, and in that format it is displayed. So this is about digital instrumentation. Now there are also advantages of digital instruments over analog one. वो क्या है? Readable, easily readable. Like if you have a dial and you have a pointer, so what is easier for you? To see the pointer and then count the number of points, is it 2.2 or 2.3, or if it is much better if you have directly displayed the value. So easy readability, and also it reduces the observational errors, like if pointer lies between here, so somebody will read it 2.1, somebody will read it 2.2. So there are observational errors, but this gets negligible or reduced to 0 in case of digital ones, because there directly the value is displayed. So easy readability leads you to the greater accuracy as well. So the digital devices are much more accurate than the analog ones. Then what is a better resolution? Like in case of digital device, in analog ones, you can just go up to millivolts कि दो बड़े divisions के बीच में, like अगर 5 small divisions हैं, like in case of scale, you can at the most measure millimeters, but अगर उसके beyond जाना है तो there can be the observational error, like if this is your scale and उसके बीच में pointer lies here, so what will you read? Either this one or this one, there is observational error. But यही अगर digital के केस में होता तो it clearly displays you 2.33 or 2.343. See, it is much more resolved. 3 places of decimal तक का आपको values मिल रहा है, but here you cannot get even the first place correctly, first place of decimal correctly. So better resolved. And also in case of digital, you have automatic polarity, like it is plus 2.3 volt or minus 2.3 volt. Your multimeter, digital multimeter, clearly displays it is positive or it is negative. Zeroing, in case of analog ones, after repeated measurements, your pointer does not set to 0 after usage of a long time. So this 0 error is most of the times there, but in case of digital devices, it automatically sets itself to 0. Okay, then storage part. Let us come to you cannot store the analog signals. Like this is a wave, of some voltage or some current, how will you store it? So you can store it, you can store the analog information, but it is much difficult. You need much larger device, like in older days. If you remember, uh, if anyone of you have seen the cassettes to record the voice sound, पहले आजकल तो गाने भी listen in pen drives, store in pen drives or hard drives, but when I was the kid, we used to have cassettes. Just Google it if anyone of have you not seen. So we used to put those cassettes in our radios or tape recorders, and then we used to listen. So a magnetic tape is there in those cassettes. So it is much difficult to store the uh, information in case of analog. तो पांच गानों का एक suppose there is a cassette. So, but today in a single pen drive you can store thousands of songs. है ना? तो पहले इन cassettes के ढेर there was a like huge bundle of cassettes, but these days in a single pen drive you can store many songs. In hard drives, many songs. Storage is much easier. So that is also one reason why we switched over to digital devices. And the most important one is storage factor, and the other most important one is the transmission factor. How you will transmit the information from one place to the another. Like if I am speaking here, you are clearly listening my voice. It's just because of the digital instruments we are having in between you and me. My analog voice is being converted into digital format and then again converted to analog one when it reaches you. तो ट्रांसमिशन जो हो रहा है दैट इज थ्रू डिजिटल, और वो क्यों हो रहा है? बिकॉज नॉइज इज लेस इन केस ऑफ डिजिटल. लाइक इफ आई एम स्पीकिंग, I am producing this amount of vibration. This is the amplitude. But in the atmosphere, when this wave will travel, this will superimpose with many other signals of around its amplitude. So it will not be possible to transmit this signal to longer distances. Only the digital format can be transmitted securely from one place. Securely in the sense without being disturbed. I'm not saying that nobody can encrypt that, but without being disturbance or less disturbance, it can reach from one place to another. So transmission is easier. Storage is much easier. So these are some benefits of digital devices, and this happens because of the use of gate circuits. Uh, so so we can build up like this: conventional, they are just of analog type, then electrical, then purely electronic, purely consisting of semiconductor devices, and they can be further, it can be analog कि अगर pointer type of movement हो, or digital. So this is the basic chart, or here the difference is the use of transistors or semiconductor devices. इसमें बहुत ज़्यादा यूज होते हैं, यहाँ पर हो सकते हैं नहीं भी हो सकते हैं ट्रांजिस्टर्स एंड सेमीकंडक्टर डिवाइसेस. और इसमें इलेक्ट्रॉनिक और डिजिटल में डिफरेंस है यूज ऑफ लॉजिक गेट्स, है ना? लाइक लॉजिक गेट्स टू कन्वर्ट इंफॉर्मेशन फ्रॉम एनालॉग टू डिजिटल फॉर्मेट, है ना, टू डिस्प्ले इट. सो ऑल things are involved here. So I hope this differentiation between the three is clear. So that is being written over here. Electronic instrument indicating, जो अभी मैंने आपको बताया, pointer deflection type और digital readout type, they can be both phase. Then there can also be recording instruments. Electronics may be like in the third unit we will be discussing about digital storage oscilloscope. So what happens? The CRO जो भी आपका output produce कर रहा है, you can store it. ताकि अगले दिन आप जब लैब में जाओ तो आपको दोबारा से वो सारा सेटअप ना करना पड़े. You can revisit that particular graph you obtained the first day. So you can record as well. So recording also हो सकता है, and controlling the amount of current passing through the internal circuit or any part of the circuit can be controlled. So there are also type of controlling instruments, automated. They automatically circuit is such, transistors are such placed, uh, transistors along with capacitors are such placed that they automatically controls the amount of current passing through the circuit. So this is basically three categories of your electronic instrumentation. Now moving forward, electronic versus electrical. Let us read it out to get a more better understanding of the things we have discussed just now. Both electrical and electronic instrument measure electrical quantities, voltage and current, etc. This we know. Electrical instruments do not have any built-in amplifying device to increase or decrease the amplitude of the quantity being measured. कोई built-in amplifying device नहीं होता. A DC voltmeter is an example of electrical instrument. It is based on moving coil meter movement. First unit में we have dealt with it in great detail, so I'm not going to repeat it. On the other hand, the electronic instruments always include in their makeup some active electron device. Active electron device here means the device in which you can control the movement of electrons. So transistor is the latest thing. Transistors जब नहीं थे, उसका जो पुराना version है transistors का, they are vacuum tubes. तो वी हैव वैक्यूम ट्यूब्स अर्लियर. वैक्यूम ट्यूब्स के बाद हमारे पास आए फेड्स, field effect transistors, and then the modified version is the present day transistors we see. So they all are semiconductor based devices. ठीक है. वैक्यूम ट्यूब, सेमीकंडक्टर डायोड और एन इंटीग्रेटेड सर्किट, आईसी जिसको हम लोग बोलते हैं, a small chip which consists of many small semiconductor components. So this is the difference. This we already discussed, but this word active electron device means in which you can control the flow of electrons. As seen, the main distinguishing factor between the two types of instruments is the presence of electron device. The movement of electron is common to both types of instrument, but the main difference being that of control of electron movement. This is the important thing. The electron instruments control the electron movement more effectively. I said that both are similar, but the more flexibility you are having in case of electronic one. So these are few advantages we have, I think, already discussed. Electronic instruments can amplify, they have high sensitivity, they are capable of measuring extremely small input. जैसे कि मैंने बताया, आप DC voltmeter अगर लो, which is electrical, जो हमने first unit में we have dealt with the conventional one, you can say, अगर उसमें small amount of current pass करोगे और वो small amount of current इतना नहीं है कि वो strong magnetic field generate कर पाए across the wire, तो this coil will not experience force and it will not move. So you need at least a minimum, depending on the type of coil you are using, minimum amount of current जो हमें उससे पास करवाना ही पड़ेगा to set it in motion to activate that device. Otherwise वो उससे छोटे currents को measure नहीं कर पाएगा. But here you can measure small input signals बहुत आसानी से. आप इलेक्ट्रॉनिक, क्योंकि वो एम्पलीफाई, उसमें इनबिल्ट एम्पलीफायर है, इनबिल्ट ट्रांजिस्टर्स आर प्लेस्ड. PMMC meter में there were no inbuilt amplification is done, but here it is इनबिल्ट एम्पलीफिकेशन इज डन, सो लो एम्पलीट्यूड सिग्नल्स को अच्छे से मेजर कर सकते हो. Due to the high sensitivity, their input impedance is increased, which means less loading effect when making measurements. इनका जो impedance होता है, इसको भी हम in the coming few minutes I will be elaborating more on this point. और आपका फर्स्ट जो टॉपिक है सिलेबस का, वो स्पेसिफिकली इट इज आस्किंग फॉर द इनपुट इम्पीडेंस. सो इलेक्ट्रॉनिक इंस्ट्रूमेंट्स का जो इम्पीडेंस होता है, बिकॉज देयर आर लॉट मेनी कंपोनेंट्स इनसाइड द सर्किट. ठीक है, पीएमसी मीटर में सिंपल देयर इज अ मूवमेंट ऑफ करंट एंड दैट कॉइल इज मूविंग. As such, no high input, and that coil is moving and the pointer attached to it is moving. There is no much impedance of the device, but here the input impedance आप जितना मर्जी अपने अकॉर्डिंग बढ़ा भी सकते हो अपनी सर्किट में. तो जो लोडिंग इफेक्ट है, जो मैं फर्स्ट यूनिट में डील किया था कि इफ योर इम्पीडेंस इंक्रीजेस, इफ योर ओवरऑल रेजिस्टेंस इंक्रीजेस, जो लोडिंग इफेक्ट है वो लोडिंग इफेक्ट कम होता जाता है थोड़ा सा, एंड यू गेट बेटर सेंसिटिविटी ऑफ योर डिवाइस. ठीक है, मोर ऑन दिस वी विल बी डीलिंग. These instruments have greater speed, faster response to the input. अब एक कॉइल को मूव करने में, to set that pointer moving, it is much slower than the digital ones, जहाँ पे इलेक्ट्रॉन का फ्लो हो रहा है the speed of light. So that is the case. It can be interfaced very easily with the computer system. Analog वाले result को आप कंप्यूटर के साथ fed up नहीं करवा सकते, लेकिन in case of digital ones you can easily feed it with the computer system, analysis कर सकते हैं, lot many things. So these are the advantages over the conventional ones. So let us have a brief look at the block diagram. Where it uses rectifiers, amplifiers to generate a current proportional to the voltage. ये this word is important. जैसा कि एनालॉग में काम करता है, जैसा कि कन्वेंशनल में हमने देखा था कि एनालॉग में अगर 1 गुना करंट बढ़ाओगे तो 1 गुना ही पॉइंटर का डिफ्लेक्शन होना चाहिए, जो हमने फर्स्ट यूनिट में बात करी थी. सिमिलर हेयर होना चाहिए. इफ करंट इज इंक्रीज्ड बाय 2 times, then the output through the transistor should also increase by 2 times. So it should be proportional. Otherwise इनपुट दे रहे हो वो तो कुछ और ही दे रहे हो, आउटपुट में कुछ और आ रहा है. So that should not be the case. Proportional increment or decrement is there. डायोड्स यूज करते हैं, डिकोडर्स यूज करते हैं, और ऑल सच थिंग्स. सो व्हाट इज हैपनिंग, इनपुट वोल्टेज आपने दिया, इनपुट स्विचिंग और रेंजिंग हुई ऑटोमेटिकली. आप कन्वेंशनल में क्या करते हो, आप नॉब घुमा करके स्विच करते हो खुद. लाइक मुझे 0 to 10 वोल्ट का रेंज में चाहिए, 10 to 20 वोल्ट की रेंज में चाहिए. हमने बनाए थे ना मल्टी रेंज एमीटर्स और मल्टी रेंज वोल्ट मीटर्स. यहाँ पर इनपुट वोल्टेज के अकॉर्डिंग इट ऑटोमेटिकली डूज कि किस रेंज पे इसको लगाएं, मिली पे लगाएं, वो माइक्रो पे लगाएं, ऑन व्हाट. फिर अगर करंट कम रेंज का लगता है या वोल्टेज, तो इट एम्पलीफाइज. ज्यादा का लगता है तो इट ऑल्सो समटाइम्स डिक्रीजेस. ठीक है, तो दिस इज द कंडीशन. एंड आफ्टर दिस योर सिग्नल इज कन्वर्टेड इनटू द डिजिटल फॉर्मेट. जो एनालॉग टू डिजिटल आपका कन्वर्टर है, इट इज बीइंग कन्वर्टेड टू डिजिटल फॉर्मेट. और अगर आप एनालॉग सिग्नल चाहते हैं तो पीएमएमसी के थ्रू आप देख सकते हैं, और अगर आप डिजिटल रीडआउट चाहते हैं तो डिजिटल डिस्प्ले आपको मिल जाएगा. सो बोथ द केसेस आर देयर. एसी चाहिए, एसी टू एसी करंट को मेजर करना है तो यू नीड रेक्टिफायर to convert that AC to DC, and then finally to analog to digital converter. So all such process wo hum already be I'm presuming that you know the working of rectifier. What does rectifier do? It converts AC to DC. हमने first unit में भी बात करी है. तो जो DC AC voltmeter होता है, it first convert that AC signal to DC signal and then gives the value to you. So this is the thing why same is written. The voltmeter will be a simple permanent मैग्नेट वोल्टमीटर सिंपल परमानेंट मैग्नेट मूविंग कॉइल गैल्वेनोमीटर होगा, वहां कोई एम्पलीफिकेशन नहीं होगा. बट इन केस ऑफ इलेक्ट्रॉनिक देयर इज एम्पलीफिकेशन. जो नॉर्मल वोम इज द कन्वेंशनल वन, जो कन्वेंशनल विच वी डेल्ट इन द फर्स्ट यूनिट is used to measure voltage but lacks both sensitivity and high input resistance. उसका जो इनपुट रेजिस्टेंस होता है हर रेंज के लिए अलग अलग होता है, ये हमने देखा भी था, है ना. सेंसिटिविटी में वी वी हमने एक क्वेश्चन भी किया था 10,000 वोल्ट्स पर ओम और 20,000 ओम्स पर वोल्ट, दो वोल्ट मीटर्स को कंपेयर किया था. तो जैसे ही आप रेंज बदलोगे, because it will connect to a different series shunt resistor, तो उस रेंज के चेंज होने के साथ साथ बार बार उसका इनपुट रेजिस्टेंस चेंज हो जाता है, और उस इनपुट रेजिस्टेंस चेंज होने की वजह से द अमाउंट ऑफ एरर इंक्रीजेस. लेकिन इलेक्ट्रॉनिक वोल्टमीटर के केस में एक पर्टिकुलर रेंज है 10 मेगा ओम टू 100 मेगा ओम, इसके बीच में आपका ऑर्डर रहेगा. तो जो लोडिंग इफेक्ट होने के चांसेस हैं वो होते हैं बट कम होते हैं कन्वेंशनल वोल्टमीटर से. सो दिस इज द केस because it automatically switches on to the range, automatically एक्सटर्नल रेजिस्टेंस बार बार ही चेंज नहीं हो रहा है, जैसे मल्टी रेंज एमीटर या मल्टी रेंज वोल्टमीटर के केस में हमने फर्स्ट यूनिट में देखा था. ऑन द सेम ट्रांजिस्टर्स बस हम फ्लो ऑफ इलेक्ट्रॉन को बदल देते हैं. ट्रांजिस्टर जो है ज्यादा और कम करंट होने की वजह से ट्रांजिस्टर इस तरीके से फंक्शन करता है कि अमाउंट ऑफ इलेक्ट्रॉन्स, नंबर ऑफ इलेक्ट्रॉन्स पासिंग थ्रू इट डिक्रीजेस और इंक्रीजेस. सो रेजिस्टेंस पे इफेक्ट आता है, लोडिंग इफेक्ट भी होता है, बट वो उस ट्रांजिस्टर की जो रेंज है रेजिस्टेंस बढ़ने की और घटने की उसी रेंज में रहेगा. इट विल नो गो बियॉन्ड दैट. तो यू कैन एक्चुअली मैथमेटिकली कैलकुलेट कि 10 मैक्सिमम एरर इस ऑर्डर का हो सकता है. बट इन केस ऑफ मल्टी रेंज एमीटर or conventional one, it is just becomes difficult for us to change. और इसका इनपुट रेजिस्टेंस कांस्टेंट ही रहता है, बिकॉज जो ट्रांजिस्टर ऑफर करेगा दैट मीन्स ट्रांजिस्टर लगा हो, ऑपरेशनल एम्पलीफायर लगा हो, या जो भी कंपोनेंट उसमें लगे हो उनका फिक्स रहता है. तो इसका जो इनपुट रेजिस्टेंस है इट रिमेन्स कांस्टेंट ओवर ऑल रेंजेस, मतलब सभी में सेम काइंड ऑफ जो एरर है वो इंट्रोड्यूस हुआ है. सो ओवरऑल एरर यू कैन फाइंड आउट एंड रिड्यूस इट. ठीक है, ऐसा नहीं है हर रेंज के लिए अलग अलग हो रहा है. ओवरऑल बिकॉज सेम ट्रांजिस्टर इज बीइंग यूज्ड फॉर एवरी रेंज, उसमें आप स्विचिंग नहीं कर रहे हो बार बार, जैसे मल्टी रेंज में हम बार बार स्विच करते हैं समटाइम्स टू दिस समटाइम्स टू दिस. तो स्विचिंग की वजह से जो उनका इनपुट रेजिस्टेंस है वो चेंज हो जाता है. बट इन हियर द इनपुट रेजिस्टेंस रिमेन्स कांस्टेंट. आई एम नॉट सेइंग इट इज जीरो, इट इज कांस्टेंट फॉर ऑल द रेंजेस. So this point needs to be highlighted. This is important one. Analog digital we have talked about. Vacuum tube voltmeter, FET I have talked about. Okay. Low level signal detection we have talked about. Low power consumption we have talked about. This point is new one. High frequency ring. जो हमारा analog, or I shouldn't say analog one, I should say the conventional one, वहां पर बहुत ज़्यादा high frequency wave you can't be using. So two reasons could be for that. When there is a very high frequency means high energy, the power loss in case of conventional is much more due to the heating effect. But here as transistors, second reason is also that is the case कि high heating effect is there, heating effect is low in comparison to conventional one. And second one is कि in case of conventional one there could be frequency dependence frequency dependence रिजल्ट इन केस ऑफ कन्वेंशनल वन कि किस फ्रीक्वेंसी की हम सप्लाई दे रहे हैं उसकी वजह से डिस्टॉर्शंस हो सकते हैं द अमाउंट ऑफ वोल्टेज यू आर measuring could be different, could be more errorful in case of conventional one rather than digital one, because digital ones uh, you in case of digital ones you can मेक देम फ्रीक्वेंसी इंडिपेंडेंट एज वेल कि आपका जो आउटपुट है वो फ्रीक्वेंसी पे डिपेंड ना करे बाय टेकिंग हेल्प ऑफ ट्रांजिस्टर्स you can do that, but you have not much flexibility in case of conventional. So there is some sort of frequency disturbance in case of conventional one, which is reduced in case of electronic ones. So I think this should not be the case. No loading errors. Less, it should be less loading errors. Less loading errors. So this is the case. So this was the basic idea about electrical, electronic, analog, digital thing. Now in particularly we will be dealing with AC electronic voltmeter. So they can be of various types, rectifier type. अगर आपको सिर्फ एवरेज निकालना हो एसी का, या सिर्फ पीक निकालना हो, या रूट मीन स्क्वायर वैल्यू निकालनी हो, so that is the different types of AC electronic voltmeter are there. But in case of अगर ये AC conventional voltmeter होता तो not much options available to you. Conventional में mostly you will get root mean square, or you will only get root mean square value of that जो हमने AC conventional voltmeter में पढ़ा था. But here if you want peak you can get electronic वाले में peak का बना सकते हो, एवरेज का बना सकते हो, RMS का. तो different types you can play with, different types, the kind of display, digital display, the kind of reading you want. You don't want peak, fine. You don't want the average, fine. You want the RMS, fine. But in case of conventional you only get the RMS value of that. Because in conventional what happens, you can using the rectifier you convert that AC signal to DC signal, and then that DC signal is converted to that you can convert it into digital format, and if not you can very well go with the analog one. So in case of rectification you just only need get RMS value, root mean square value of the AC voltage. You can't get the average one, you can't get the peak. You can mathematically calculate, but direct display was not there. So here you can have flexibility, you can design as per your want, as per your need. So this is the case with the AC electro. इसलिए specific mention is there of AC electronic voltmeter, because sometimes you need average, sometimes you need something else. Sometimes you need higher frequency measurement, like radio frequency अगर आपको measure करना है. So a lot of things you want. So specifically we will deal with AC electronic voltmeter. AC electronic में भी AC electronic millivoltmeter, and we will be talking कि why milli, why it is difficult for us to make millivoltmeter in case of conventional वाले में. मैंने जैसे आपको बताया ना कि अगर मिनिमम अमाउंट ऑफ करंट भी नहीं दोगे तो वो कॉइल मूव ही नहीं करेगा जो वोल्टमीटर का है. तो कॉइल मूव नहीं करेगा, उससे अटैच्ड एनल जो पॉइंटर है वो मूव नहीं करेगा. तो मिली तो बहुत कम वोल्टेज हो जाता है ना, 10⁻³ यानी 0.001 वोल्ट. इतने वोल्टेज पे मैग्नेटिक फील्ड जनरेट करवाना, उस कॉइल को मूव करवाना, इट बिकम्स डिफिकल्ट. सो दैट इज व्हाई it is suggested to use AC electronic voltmeter. You cannot go with at such low voltages, millivolt pe. At such low voltages, you cannot use the conventional voltmeters. It will not work. So we will particularly deal with that AC electronic millivoltmeter, and that is part of your syllabus. So With this, I want to end, and I hope I had made it clear between all kinds of instrumentation, electronic, electrical, digital, and analog. So, thank you very much.